So optimization, this isn't posted yet, but it will be. Answers are already posted though. Find two positive numbers, we'll call them x and y, such that the sum of twice the first and 3 times the second is 150, and their product is a maximum. So I'm not worried about the product is a maximum yet. If the sum of twice the first and 3 times the second is 150, Luna, you're waiting. What does that mean?
2x plus 3y equals 150.
Yeah. So a little bit of translating math into English there. Or no, English into math. Twice the first, 3 times the second is 150. And the product is a maximum. Okay, step 1. You are finding an absolute maximum or minimum. Well, in this case, a maximum. And with absolute, that means, well, you tell me, this was on the most recent test you took yesterday. If it specifies the absolute max or min, what do we need to do? A table. So candidates test, closed interval test, that's the fancy words for it. But yeah, we'll need a table. And what do we need to include on that table? Oh, kind of jumping ahead.
Critical numbers.
Critical numbers and endpoints. So we'll be making a table with critical numbers and endpoints. Okay, that's big picture, because critical numbers of what? We don't even have an equation yet. Ask yourself what is being maximized or minimized, and write the equation for that. So this is where people start to get confused, because we have an equation, 2x plus 3y equals 150, but that's not the main equation. That's not the main thing going on in this problem. The main thing is maximize their product. So I just need to invent a variable to stand for product, probably P, but you could call it whatever you like. So what's an equation that will tell me their product?
No clue.
What does product mean? And back up one.
Oh. The
Multiply.
Equals 150. Well, no.
Let's see. Their product is a maximum. So the product of x and y. So the product that we want to maximize is just x times y.
Okay.
And we'll call that our primary equation, because that's the one we want to maximize. Now, there is another equation lurking in the background. That's our secondary equation. Step 2, write the equation for what you are trying to minimize or maximize. So that's the P equals XY. In terms of only one independent variable, if possible. I think for us it's always going to be possible, because if it's not, we'd really be stuck. This usually involves other information in the problem. So I'd like to maximize P, which is x times y. Maximize means I'll need to take a derivative to find those critical numbers. But taking a derivative right now would be
1 times 1.
well, no, I'd have product rule,
dx dy.
and I'd have dy dx or dx dx, or it's
Something like that.
it's ugly right now. So I want to use that other equation and solve for one of those variable, and so that I can change this equation to only have one variable in it. 2x plus 3y equals 150. That's our secondary equation, our helper equation. I'm not minimizing or maximizing that. I'm not taking a derivative of that. But I am going to use that. It's going to help me. So I'd like to solve for x or y, and it doesn't really matter which one. Solve for one variable, and then substitute into the primary equation. for one of the variables and substitute into the other equation. So it doesn't really matter. I guess I'd say we usually solve for y. So that, I don't know, that's what makes sense to me on this one. Sometimes the math and fractions work out where one of them is easier than the other. But it doesn't matter. 3y equals negative 2x plus 150. So y equals negative 2/3 x plus 50.
Is this just the system of equations for me?
Kind of, except we're not solving. We're just using one of them and plugging it into the other. So there's definitely some similarities with systems of equations where you, by substitution, where you solve for one and plug in the other. That is what we're doing. So there's my expression for y. So I'm going to plug that in for y. Negative 2/3 x plus 50. So p is negative 2/3 x squared plus 50x. Okay, a little side note on step 2. If necessary. Sometimes they give you an equation that only has one independent variable in it. We like those because then you don't have to do this step. It's kind of ready to go. Step 3, analyze the equation and or situation. Can you tell if this equation does indeed have a min or a max? Which one are you trying to find? Can you tell if it has a max or min at a relative extrema versus an endpoint? And so this is not like a formulaic thing. This is like, look at what you've got, see if you can figure out what that shape is, and then maybe make some conclusions. So 2/3 is kind of weird, but what's the shape of negative 2/3 x squared plus 50x? Parabola. Okay, good start. Can you be more specific? Can you narrow down what that parabola looks like based on what you see here? There you go. Yes. How did you know it was that?
It's negative.
Because it's negative.
The x squared is.
So it's a downward parabola.
It is concave down.
It won't always be a downward parabola. It won't always be a parabola. Sometimes you may not be able to tell what it is. It might be really weird and you're just like, I don't know what's going on. But sometimes you can look at it and think about what you've got. So what were we trying to find on this one? The maximum. So again, I'm not really doing calculus. I'm just kind of thinking about things. That a downward parabola is going to have a maximum. So I'm looking for that maximum.
So now you take p prime?
So now let's take a derivative. Find your critical values, step 4. Find your critical values. Why do we do this? Why we... So critical values would be where p prime equals 0 or undefined. Why do we care where p prime is 0 or undefined?
Because that's where that max is.
Yeah, there's a flat spot for maxes or min, so just generically a graph there. Our critical values give us our possible maxes and mins. So p prime or dp dx, either way. Let's see, it would be negative 4/3 x plus 50. Let's set that equal to 0 to find our critical points. x equals 50. X equals 3 times 50 is 150 divided by 4. That's a safe stop answer, but 75 over 2, 37.5, but 75 over 2 is fine. So that's our critical point. Take the derivative, set it equal to 0. That, when we say find your critical values, that's the same thing as take the derivative, set it equal to 0. If you're not sure your critical number is a max or a min, use a sign chart. So that would be like a number line with 75 halves over it. Now, on this one, you could argue that we don't need to do that because we know that this is a downward parabola. So the only critical point is that vertex, and it's a maximum. So I don't really need to do this, but if I wanted to, I could check something less than 75 halves, something more than 75 halves.
76 halves.
76 halves. I'll just do 40. But if I know it's a maximum, I'm kind of cheating on this one because I know what the answer should be. Right? It should tell me that P prime is positive over here and P prime is negative over there because I already know it's a maximum. Let's see. Be sure to consider the endpoints. Okay, well, we didn't have endpoints on this one. It didn't say between 0 and 12 or whatever. It just said find it. And then step 5. This one is so many people lose points on step 5 because they do all the calculus. They're relieved. They got 75 over 2. I'm done. Well, go back and reread the question to make sure you answered exactly what was being asked. Answer the specific question. Yes, this is an often missed part of the problem. So, what was being asked?
You have to find 2.
Find 2 numbers. Okay, well, I've got x. X is 75 over 2. I need to find y. Plug it in where? I got a whole lot of stuff going on.
The 2x plus 3y.
Okay, so a couple places. You could plug it in right here. You've also already solved for y, so you could put it in right there.
But you have to deal with fractions that way.
Well, if you plug it in here, you're going to have to eventually deal with fractions.
And you have to do multiplying fractions.
I'm going to plug it in here because that's the simplified version. Negative 2/3 x times 75 halves plus 50. And as a safe stop, that's fine. Like that would be an acceptable safe stop. Multiple choice test is not going to stop there. Let's see, the 2's cancel. 75 over 3 is 25. So the 2 numbers are 25 and 75 over 2.
Did you just write x equals 75 over 2 and y equals 25? Or?
Yes. Be careful. You don't have to put it in a complete sentence, but make sure you've answered the question. Because sometimes, and we did this on the test yesterday, one of the last questions was find the equation of the tangent line and then use the tangent line to estimate something. Well, you've got to make sure you answer both questions. And I just thumbing through, I saw a few people that found the estimate, but it never really clearly said what the line was. And so make sure you answer the question and it's clear you know which answer goes with which question. Number 2. By the way, we're going to stop at number 3 today, and we'll do the rest on Monday. A ball is thrown straight up in the air from a height of 3 feet. Okay, this is kind of physicsy here. its height after t seconds is given by, okay, well this is not physicsy, like they're just going to give us the answer here. What is its maximum height? So I want to maximize S. Let's think through the steps again. So step 1, what are we doing? Finding the max of what equation? Oh, this is nice. Because why is this example nicer than the last one?
Because it only got one variable.
There's only one variable. I don't need there's not a secondary equation because I don't need a secondary equation. This is the equation we want to deal with, so we like it. Like this just gives us the equation to optimize. This is a good one. We like this one. So a maximum height would be where S prime is 0. In fact, let's think about this. It's another negative parabola. So somewhere there is going to be a maximum height. What is its maximum height? Okay, so ds dt, or S prime, negative 32t plus 20. Remember, I want to know where that tangent line is 0, where that slope is 0, because that's where it reaches its max. So I'm finding my critical number, and there aren't really any endpoints, but I don't have to worry about it because it's going to be whatever we find for a 0 slope, that's going to be the max. 32t equals 20. T equals 20 over 32. Again, that's an acceptable answer, but I should reduce. It'll say, divide both sides, or divide top and bottom by 4, 5/8. And t is in seconds. Okay, is that my answer?
No.
Why not?
Because you have to find the height.
Right, so again, read the question. It could have easily said, find the time where it's at its max, and that would be our answer. But it asked, what is the maximum height? So the height is S. So I know the time. So I know the time of maximum height. What do I do to find the actual maximum height? Plug it in. Into where?
The original equation.
Into the original. So S of 5/8 negative 16 times 5/8 squared plus 20 times 5/8 plus 3. Thank you, sir.
Yep. That's your butt.
From Miss Morris. Suspect. Very suspect. And let's call that our final answer, because I don't want to square 5/8 and multiply by 16. And so this is our answer in feet. That is our maximum height.
I used it.
Yeah, sorry, it's one of each, so it's actually that's pre-cal.
Oh, it's pretty cool.
Nose and calendar. What is its maximum height? We found the maximum height. Just making sure it didn't ask for anything else. Okay, so we're good. Found its maximum height. Take a derivative, set it equal to 0, and then either examine what you have, because you might already know what it is. If not, then put it on a number line and check and see what's going on. Number 3. A rancher needs to make an enclosure. Miss Murray wrote this, and she told me, she goes, please make fun of me, because I don't know what I was thinking. So yes, a rancher needs to make an enclosure I think that's supposed to be an
Closure.
enclosure for his herd. The enclosure will have two areas sharing one side, as shown in the figure below. The rancher has 500 feet of fencing to use. What dimensions of X and Y in the figure will produce the maximum enclosed area? But what dimensions are we looking for to maximize area? Okay, a lot of stuff going on this one. 500 feet. Something.
Something times X times something times Y equals 500.
Okay, so something adds up to 500 because he's got 500 feet of fence, and presumably if he wants to maximize his area, he'll use all of the fence, right? He's not going to leave half of it in the barn. He's going to use all of his fence. So what could we do with 500 and these dimensions?
Well, area is. We would just multiply X and Y, right? Yeah.
Okay, so area would be X times Y, and that'll be our primary equation. That's what we'll take a derivative of in a moment, because that's what we want to maximize.
Equals, 2X plus 2Y in this case.
So, yes, perimeter of a rectangle equals 2X plus 2Y, but that's not the picture we have here.
Which one are they wanting to measure?
So you just got to count them. There's an X, there's an X. Maybe it helps to label them even. So yes, Landon, 3 Ys. 2 X's and 3 Ys.
This is just the first problem, but with 500 instead of 150.
Yeah. So 2 X's plus 3 Ys. So this could be a real world problem. Like maybe the farmer needs like 2 separate enclosures, and he wants them to be as big as possible. So like how does he arrange his fence to make this happen?
He plays with it until he figures it out.
So what do you want to do next? I don't really want to take a derivative yet because that would be yuck. I want to get rid of a variable. Would you like to solve for X or solve for Y?
Y.
YX. YX. WHYX. Why would you like to solve for X?
There's a 2 on the bottom.
I think I agree with you. Yeah, there'd be a 2. So rather than dealing with 500 over 3, we'd have 500 over 2. So yeah, let's solve for X. So negative 3 halves Y plus 250. So area is, in place of X goes this expression for X. Negative 3 halves Y plus 250 times Y. So let's distribute negative 3 halves Y squared plus 250Y. Do we know what shape that is?
Parabola.
Another upside down parabola, so there will be a maximum. This one does have endpoints. We don't really have to worry about them because we know we're going to hit at the vertex here. But you just be careful on some of these word problems. You can solve them all out and get like X equals negative 12 would be an answer. And you're like, wait a minute, I can't have negative 12 fence length. So mathematically you can get answers that don't really make sense. So make sure you're paying attention. Let's take the derivative of Y, or derivative of A with respect to Y. So negative 3Y plus 250. Set that equal to 0. So 3Y equals 250. Y equals 250 over 3.
483.3.
Whatever that is, we'll leave it as 250 over 3. Although this rancher probably wants to know what that is if he's trying to measure out his fence. But we'll leave it as 250 over 3. Have we answered the question?
No.
What dimensions of x and y. Okay, so well, I got y, so I'm halfway there. With dimensions of x and y. So I need to go plug this back in to figure out what y is. Negative 3/2, 250 over 3, plus 250. You could leave it like that and be fine, but this one works out kind of nice. Negative 125 plus 250. So x is 125 feet. Take a derivative, set it equal to 0, because that's where the max or the min happens. Let's reread this question one more time to make sure we've answered it. A rancher needs to make an enclosure. An enclosure for his herd. The enclosure will have 2 areas. Got it. The rancher will have 500 feet. What dimensions will produce the maximum enclosed area? Okay, I think we answered everything. Do you know what else they could easily ask on this problem?
What's that one y there?
We found that.
Minimum, maybe?
Okay, they could ask the minimum area. Do you know what the minimum area would be looking at that?
Yeah.
You probably don't, but if you let y be 0 and you just ran the track of fence x equals 250 feet down and 250 feet back, there's your minimum area. That wouldn't be much of an enclosure, but that would be your minimum. So that it probably would not ask for a minimum. What else could it ask for?
Minimum.
Like without changing the problem, it could ask you for the area. And so you'd have to go back and figure out, well, what do I need to do? A equals x times y. So make sure you read the question carefully, because we could ask for x or y or both or area or the area of one of the square. I mean, make sure you read the question. Yes?
Will some of these questions ever include units of measure on them?
Not usually on these, because it's usually simple enough. Usually units of measure is if you take a derivative, what are the units of the derivative, is usually when they ask for units. Here, the units of the derivative are weird, and so they don't really want you to do that. In fact, yeah, the units of that derivative,
Get all screwy.
it would be feet squared per feet, which is a weird. Right, but it's not really just feet. I mean, it would simplify to that, but it's how is the area changing based on how you change x. So feet squared per feet,
Numbers.
which is weird. All right, so let me give you the worksheet packet for the units and today's assignment, Friday,
1 through 7.
worksheet 1, 1 through 7.